to determine a and theta. Okay, so we have a right angle triangle here, so we can use our rules. So sine of theta is equal to opposite of this one, a over 14. Again, not going to really help us out because we have two unknowns here. Let's try cosine. Cosine of theta is equal to adjacent, which is 10, over hypotenuse, 14. Fantastic. Great, now let's just solve for theta. To get rid of this theta, I can't divide by cosine. This is not a multiplication operator. This is cosine of theta. The only way to get rid of that is use the cosine inverse operator on the whole thing. Same with this side. Cosine inverse operator on the whole thing. Whatever you do to one side of the equation, you have to do the other side of the equation. So they're identical on both sides because it's an equal sign. It's equal. Whatever you do to this side equals the same as whatever you do on this side. So cosine inverse of cosine will give you nothing, and it will leave you with just theta. Cosine inverse of this side will be cosine inverse of this side. In your calculator, cosine inverse, shift cosine inverse, divided by, or of 10 divided by 14, bracket closed, equals 44.4 degrees. Make sure your calculator is set in degrees. It will give you an answer in degrees. If your calculator is set in radians, it will give you an answer in radians. Here we can try something else. We can take the angle. Let's do Pythagoras theorem here. So I know that a squared plus b squared is equal to c squared. Here I have a, there's b, there's c. Let's solve for a. So we need to get rid of this b over here. Subtract b squared, subtract b squared. A squared is equal to c squared minus b squared. We're going to get rid of that to the power of 2. Bracket open to the 1/2. Bracket open to the 1/2. Left me with a, bracket open, c squared minus b squared, all to the power of 1/2. Put in some numbers. C squared is going to be equal to 14 squared minus 10 squared, bracket closed, to the power of 1/2. 14 squared minus 10 squared equals square root answer 9.8.